Welcome to Let's Explore with your Resident Evil, me, Blades, doing his rambling stuff. So let's get this cooking. What do I have for you today? We have start your engines. Yeah, let's do that. To start our engines, we need to look at what OpenGL is. So that's okay. Going to edit mode. Yeah, okay. Compile output. I've been messing around with this. So let's get into the exploration main area. Here we go. OpenGL, Open Graphics Library, free for all. It's open. OpenGL 3.3. What's that all about? It's the first modern OpenGL. Let's see, it was released in March of 2010 at the same time as OpenGL 4. Yeah, surprising. OpenGL 3 relied on gave access to Direct 3D 10, and 4 gave access to Direct 3D 11. As we're not using Direct 3D, I don't really care. If you're using Direct 3D, you do have to care. But for us, we're going to use 3.3 because it's the first OpenGL which is really modern. 3 tried to be. 3.2 nearly was. 3.3, yeah, we cracked it now. We're on our way. Are you really programming in OpenGL 3.3? Well, there's an interesting question. Let's ask the computer. I've included QDebug because I want to ask it a question. And the question I want to ask is, what OpenGL are we using? This could surprise people. Debug. Let's have a sentence. OpenGL version, and I'll just put brackets with, let's see, %s. I want a string. I want the computer to give us a string. Yeah, that's looking good. Comma. And it's just going to be GL get string. And in here, I want the GL version, please. There we go. And let's run that. I want the application output as well. There we go. OpenGL version 4.5 compatibility profile from a Mesa. Yeah, whatever. That's what I'm actually programming in. Yeah, but I asked for 3.3. Well, it's got a compatibility profile on this machine of 4.5, so there you go. That means I've got access to 4.5 stuff. Interesting. OpenGL is a state machine. It doesn't really try to make its mind up about much. It's just a bunch of switches that you can switch on and off on a graphics board. So your graphics board that you got slotted into your machine gives you your OpenGL. Not really your programming. Interesting. Yeah, I find it's interesting. But hey ho. Where are we up to? Oh yes, OpenGL 3.3. Initialize GL. Yeah, we'll do it here. Who cares? We'll have to do it here for now. Test 2. I'll just put some lines in. And how does OpenGL 3.3 or modern OpenGL work? Well, it works completely differently to what we've seen so far. It's not direct. it uses buffers. How can you explain it? So you get 32 buffers. Yeah. So imagine numbers 1 to 32 down the left hand side here as 32 buffers, 32 lines of memory which you can write into. Each buffer can contain any data you want. Yeah, I think we're going to probably use about 3 to start off with. Oh, no, actually we're going to use 1 to start off with because we're doing the triangle silly thing again, aren't we? So we're going to use the first one, which is 0, by the way, not 1, and it goes to 31. And each of the blocks is an array. An array is literally an area of memory after an area of memory after an area of memory in a list. It's like a list. So each block of memory is an array. So you've got an array of 32 lines of information. And that's how it's done. It's stored exactly like that in a big block of information on your graphics card. How big is that? Well, it depends how big your data is, doesn't it? As simple as. So how are we going to do this then? Well, we're going to need a buffer. Well, we're going to need that. We're going to take the first buffer available on the graphics card. And we're just going to treat everything by default because that's what the graphics card is defaulting to at the moment. And we're not going to do the second part of the modern bit, which is the OpenGL shading language, or GLSL. We're just going to do the first bit, which is the buffers. And leave your graphics card in default mode. We're not going to switch any switches there. So that'll do us. We'll need a buffer, won't we? Yeah, that's a good idea. Exploration.h. Let's have a buffer. We'll take whatever you were given. So that's a GL uint. I'm going to call it, though, our vertex buffer, so I know what it is, because that's what we're going to be using. And this is going to be GL vertex for us. If you remember back to here, our vertex buffer, we're going to fill in with these numbers here. In fact, I could use these numbers here, couldn't I? Yes, I could. I'll be back to you in a second when I need these numbers. So there you go, vertex buffer, control save. We need to make one. And we can do that quite easily by asking OpenGL to do it. We want OpenGL to generate, they've abbreviated it to gen, buffers, pluralized it. We only want the one, and it wants a star buffer. Okay, so that's the address, which is the ampersand sign of our, I didn't put M before it, did I? Did I not? Bad me. Mark it with an M, please. It's a member variable, means it doesn't die when we hit the next. It doesn't die until we hit that close bracket there. Go back, because it's in scope for all of these. M underscore, and it's vertex buffer. There we go. That's the command. So we're switched that switch. That switch now means that we are going to be using that as our vertex buffer. I don't like vertex buffer. No, I've just gone off that name. I'm going to call it vertex buffer ID. Because you know what ID means, don't you? Identity. Yeah, okay, yeah. ID. Let's put it in English. Let's tell ourselves what it really is, because that's what it really is. It's just a number to identify which buffer. And OpenGL is going to give us that number to identify the buffer with. It'll probably be 0 because that's the default one. Let's see, what can we do with that? Well, we now have to switch the switch. We have to switch it on. So it's called binding, bind buffer. And we're going to bind it as a GL array. Remember, I said it was an array of buffers. So we want an array buffer. Does that make sense? And we want the buffer. So m_vertex buffer ID. So we are binding the array buffer number vertex buffer ID. I just said it's probably 0, which is the 0th buffer in the first GL array. So I said they're held in arrays of 32s, 0 to 31, and then 32 to 63. Yeah, inclusive, by the way. There we go. So, what we're going to put in it? Well, we better have some vertices. Oh, God help me with Latin. Vertices. So, let's have some of those. Vertices are floats. Remember, I kept putting F's after them. Yeah, little F's. Yeah. So the floats. There we go. Float. Verti. I'm going to have a problem with this one, aren't I? Vertices, is that how we spell it? Let's call them verts. Okay. Let's abbreviate it because I'm bad at spelling. How about that? So we need an array of verts. Array. We don't know that. Well, we do know the size of it, but it'll know the size of it any second now because we're about to define them. Equals, and we're going to use a scope. And at the end of the scope is a semicolon. I don't know why it's done that. Never mind. And our first vertices are going to be them 3 there. Copy. Paste. Put a comma at the end. Always remember to put the F after the floating point number. If you don't, yeah, very funny. Why it does that? Interesting. I think I found a bug in our Qt Creator. Next line is the next lot of verts. Copy and Control V. Put a comma there. Now that's why. Okay. Next line. Those vertices. I'm not going to be taking the colour for this one. So at that point we get complicated. Well, not complicated, but okay. Let's just pop you over by 1. You over by 1. You over by 1. That's it. That looks nice. So we've got our verts, our original vertices from our 1997 OpenGL, and we've popped them into an array. An array, by the way, is just a way of saying a set of numbers, a list. Yeah, a list of numbers. Now, this list of numbers is continuous. It doesn't just go into a block like this. It's just a continuous lot of numbers going across. That's what the commas are for. And the last one, you can put a comma there if you want to. If you forget, just put, and you don't, or you don't know, just put a comma at the end. It doesn't actually matter. It doesn't register it. Right, so we've got some vertices. We've got ourselves a buffer. we need to add our vertices to the buffer. Now, OpenGL isn't really strange in anything. It just says that we're going to use buffer data. This is where it gets strange because we've got a load of switches as well here. So the switch is GL buffer. Array buffer. Wants to know which type of buffer. It's the one we've got bound. So what we're doing is we're telling OpenGL that the GL array buffer, which we have bound currently, is the one we're going to use. We're going to tell it the size of our verts. I think that's the easiest way of putting whatever that was. We want the data itself, so the verts, and we want to know the usage. Well, we're not going to be changing them, we're going to be drawing them, so it's going to be GL, not changing is static, so very static in this case, and it's draw. That tells OpenGL, or gives a hint to OpenGL, where to store our data. Should it be closer to the GPU or further away? Because remember, we've got a lot of memory on our graphics cards nowadays, and the closer it is to the GPU, the faster it is to access. Distance matters in nanoseconds. It matters a lot, so it's quicker the closer it is, the memory the closer to the GPU or graphics processing unit, the chip that runs your graphics. That's it, that's all we need to do. So we have taken our vertices and sent them onto the graphics card. That is now on your graphics card. It's no longer on the machine. It's no longer on your machine, it's no longer in your memory here. It's been tootled off down the memory and into the graphics card. And that's that. So, what we're going to do here is put else if m_test is equal to 2, we want to draw the data in that buffer. Now that buffer's got 9 floating numbers in it. In a long line of memory, just 9 floating point numbers. How on earth is our poor GPU, how is it going to know what to do with it? Well, normally I'd say, well, we'll send it through the shading language program, but we haven't written one. But we will write one, don't worry. But for now, we're just going to rely on OpenGL's default, and its default means that we have to flick a couple of more switches here. And the first one is to enable. So we need to enable that one there, the vertex attribute array. That will tell OpenGL the kind of attribute that these numbers represent, which is a vertex attribute. There we go, we'll take one of those, and it's on slot 0, so we'll take that as the first one. We're just using the default slot, or the 0 slot of memory. As I said, it's probably going to give us 0 here. It does actually, for this ID. So Ignore that, it's just a switch we flicked. Now, we have to tell it what a vertex attribute is. It doesn't know. It doesn't know how many floats to use as one vertex attribute. It knows now that it needs to treat them as vertex attributes, but it doesn't know how many at a time. Now a pointing space is 3 floats, X, Y, and Z. You would think it would need 3, but it doesn't. It only needs 2 because our screen is 2-dimensional. You could miss out the 0, 0Fs. You can take that line out totally, and it would still work as long as you told it there was only 2 for an X and a Y for 2-dimensional drawing. Yeah, so it doesn't know. Are we using 2? Are we using 3? Well, let's tell it. So our vertex attribute, it's double T, attrib, and it's our pointer. We need the pointer, so it's that bottom one there, attrib pointer, and it's going to ask us a lot of questions. So the gluint index, well, we decided it was 0, didn't we? We just pretended we knew. And I said 0, so there we go. Size, it's 3. How do I explain that? How many floats it's asking for? So it's 3, comma, type, we'll call it a GL float, because it's on the graphics card. So it's OpenGL float, it's not one of ours. Normalized, not got an I don't know. I know what it means, but normalized means do those 3 numbers make a vector sized 1? So we'll say no, they don't. So that's false. I don't know what size. They're not vectors of points of positions, so no, I'm not even going to go into vectors at the moment. What's the next thing it wants? Stride. Is there any distance between the first set of 3 and the second set of 3? Remember, I could have put colours in there. I could have put then that I wanted the colour information. So it would have had to go from there, first 3, to the second 3, past the colour. Would have had to make a jump. So you can use stride to indicate that. We don't have one. And the last one is where everybody I see puts a 0. Star void pointer. Where are we starting from within our line of data? Well, we're starting from the beginning, which is 0, and that's wrong. And luckily, for once, I'm using an editor that tells me that it's wrong, and it's telling me that I am using a 0 as a null pointer constant. You can't do this, and you'll see everybody online doing this. It isn't 0, it's a null pointer, it's a pointer. It is 0, that means 0, but it's a null pointer, that means something slightly different. That means it's a pointer to the first location, whereas 0 just means 0, doesn't mean anything. There we go. Sorry, a rant. Oh, that one irks me. Now, we've told it what the information is, and that we've got 3 floats. We've told it that it's a vertex attribute. So really, that's it. That's all it needs to know, I think. So what I'm going to do is I'm going to draw this array that we've made. So draw arrays, we've only got one, don't tell it. We want to draw triangles, remember? This is where GL triangles comes up. So we've got the numbers in our buffer. on the graphics card. We want to draw them as triangles, so we'll do that. So it's going to be GL triangles. The tab. Thank you. Comma. First is 0. And size I count 3. 3 vertices in total, yeah. That's all there are. That's the number of vertices we typed in, 3. That's a semicolon, yeah. So just have a look again. It was 1, 2, 3. Yep, that's right then. Shall we try running it? Ah, wait a minute. mtest equals 2. We haven't got one of them. I'm going to say it, aren't I? Need more buttons. Vertical layout. That'll do. I need a vertical layout. Can put it on the right hand side of that button, or I can put it on the left hand side of that button. Right is, come on, where's left? There it is. Got it now. Put it on the left, and test 1. I'm just going to slide into it. It's there, isn't it? There we go. Right, so if I get another button and drop it in there, it went to the wrong side of it. Down, please. That's better. Double click on it, call it test 2. There we go. So rename it here. Hey you, get off me. And we'll call it button underscore. I'm just going to call it test 2. I know it's not test 1 there, but hey ho. Never mind, that's what we labelled it last time. So we've got a test 2 button. Let's go to its slot. On clicked. And type in our famous words here. Copy that. Paste it there. Put a 1 in there. And put a 2 in there. And change that to a 2. And that's it. We've got a new button. Is it that easy? Well, yeah. It is that easy. Well, it should be anyway. Soon find out. It's compiling. There we go. OpenGL version 4.5. Yep. Test 2. Well, that's interesting. Test 1 gave us the coloured one. Test 2 gives us a blue one now. Have you noticed something? Yes, it was white to start off with. Clear. And now it's blue. That's because we left it at the end in blue. We did RGB. We never turned the colour back to white. So when we do test 2, the colour bleeds over. So that's interesting. We've just found out something about OpenGL. It's a state machine. Whatever state you leave it in, it will continue to have. I think I know that the buttons are being clicked now. Can I get rid of these because they're annoying me now? Handy if you want to know what's going on, but annoying if you don't. Too much information is sometimes a bad thing. There we go. Yeah, okay. Are we happy with OpenGL? Did it make sense? Yeah. But Blaze, why did you write it all in here? Yeah, why? Because I knew it would work in here. These are all OpenGL commands that we have access to in here because we have initialized OpenGL. But hold on a minute. I want to move this outside so I can just put initialize and draw. Because that would be a lot easier than all this rubbish. Well, try it. See if you can do it. There you go, homework. And in the next episode, I'm going to try it. And I'm going to try and do it. That'll be fun, won't it? Let's have a look. How long are we on? Yeah, we're on 30 minutes now, and it's a simple OpenGL example. And you spotted now that it's a state machine, and I wasn't lying to you, and it was colour bleeding over. I can actually change the colour here if I wanted to, but I don't. I think it proves a point, so I'm going to leave it like this for now, and in the next episode I'm going to attempt to take this out of here and see what is needed to carry on this state machine in this way. That'll be interesting. Yay. And also I need to think about what was it? Mouse and keyboard. And we are going to cheat on that one, I must admit. Mouse and keyboard. It's just that I know that we've got a very, very good program for mouse and keyboard events, and it's handy to us, and we can just probably copy and paste it. So that's going to be a very nice, easy one. Test 2. Yeah, okay. Explore 3D. Let's explore source. Test 1. Create a new folder. Test 2. And let's see what you come up with. See if you come up with the same thing as me, which is impossible. I don't know what it's going to be yet. So, yeah, interesting problem to solve. How do we get that out of this slot here? How do we unravel it from here and put it into a function or a class of its own test, into that folder? So I'll give you a handy hint. We're going to have source, add new, class, choose, test 2, browse to there, choose test 2, yeah, next. I'll add it to Git, there we go, finish. Lovely. So I'm going to start at exactly the same place as you with that. There we go, there's a header file, it's already set up for us. Everything's happy, joy. Good luck. Let's see what we can do with test 2. Catch you in the next episode. Take care and have fun.